Cody Woolery, give me an example of a variable. Cody? Cody, I know you're in here. Give me
What?
an example of a variable.
I don't know. Yeah, I don't know.
No, you do know.
I don't, though. That's a thing.
No, I don't know is a cop-out because you do know. I need an example of one.
I can't.
You make it up.
Um,
I'll tell you what, 5 is not a variable.
Wait, can I get...
yeah, I have no idea. Oh, wait, isn't it?
A letter.
What? Oh, X.
X. X is the most famous variable. Laura, can you think of another variable?
Y.
Laura, Y. These are 2 examples of variables. A variable, it's very easy, is a letter that represents a number. All right? And no, that's not the hashtag symbol. It's the pound symbol. It's the number symbol. Okay? Now, Ed, can you give me an example of a constant? I'll give you a hint. It's not a letter.
It's 5.
5 is a constant. Julia, can you give me an example?
8.
8. These are perfect constants. These are numbers. Constants are numbers. Okay? So like those things, like 5 and 8, they're not attached to a variable. They're just out there. An expression. Well, if we want to know what an expression is, let's figure out what an equation is. Jake Stevens, what does an equation have? There's one thing that makes it an equation. What is that one thing?
Equal to something.
Very good. An equation has an equal sign. So, Amelia, an expression is what?
Without an equal sign?
Very good. So an example would be like 2x plus 5. Notice no equal sign. The x part is your variable and the 5 is your constant. Here, y minus 8. The y is your variable, the minus 8 is your constant. So an algebraic expression is an equation with no equal sign. And like I said, these aren't formal. Some math person out at like Penn State is probably having a heart attack because I am defining it like this, but it's meaningful to you. You know what that is. Now a term, all right, are the parts of an expression. Oops. All right, so it's easy enough. All right, so down here we have an example, x squared minus 3x plus 6 equals x squared plus negative 3x plus 6. All right, so there are, it's not saying an equation, it's an expression. Okay, what they're saying is this over here, all right, has 3 parts. This this, and this. Now, the way I kind of remember it is if you have a plus or minus sign, that's where you divide up your expression. So notice, there's a minus sign right there. There's a plus sign right there. Notice I divided my expression up into 3 parts. That's how I know there are 3 terms. The term x squared from the above equation has a coefficient, meaning the number in front of your variable of 1. Notice there isn't a 1 there, it's understood to be 1. And the term negative 3x has a coefficient of negative 3. Okay? And the constant is 6. So down here in example 1, we're going to go through it with me leading it, and you guys just follow along. All right, so I need to figure out what are the terms of this expression. So what I'm going to do is at every minus sign or plus sign, I'm going to draw my slash. It divided it up into 1, 2, 3, 4, 5 parts. The 5 terms are 3a, negative 5ab, 9a squared, 4ab, and negative a. Notice I don't write the plus for positive, but I do write the negative when it is negative. Now my coefficients, all right? For the 3a, the coefficient is 3. For the negative 5ab part, the coefficient is negative 5. For the 9a squared part, the coefficient is 9. And for the 4ab part, okay, the coefficient is 4. And last but not least, the hardest one is the negative a. The negative a has a coefficient of negative 1. All right? So those are all my coefficients. Now, we could argue and combine things, but that's not what we are doing right here. We're not at that stage, because that stage is example 2. Now, I like to think of combining like terms is a little kind of like TLC, right? Or CLT. So like terms are things that look the same, right? They have exactly the same variable, okay? With the exact same exponent, all that fun stuff, right? Any questions on that? Good. So as an example, let's rewrite A from above. And Hannah, give me 2 things in this expression that are like terms.
Negative 5ab and 4ab.
So when I do this, I like to use colors and shapes. So that's my red piece, okay? My red circles. Liam, can you give me another piece that's a like term? Liam.
Oh, 3a and negative a.
Okay. So my green squares are like terms. Now, when I'm doing the combining part, I am going to combine these two things together. So I don't do anything with the exponents or the variable. I just deal with the coefficient. So negative 5a plus 4a is negative 1, sorry, ab. So it's negative 1 ab. Now for the green part, we have 3a minus a. That's 2a. And last but not least, this guy doesn't have a partner. So that is just 9a squared. Now you can see that coefficients, when simplified, like it's more meaningful. Like in the problem above, yeah, we have a ton of coefficients and terms, but I'd much rather deal with this example where we combine them, okay? Because it's a lot neater. So down here, there are 3 examples, A, B, and C. You got 1 minute to do it. Go. Combine the like terms. All right, let's get to getting. It may have been a minute, may have been less than a minute, but I can't wait. So, Franklin, I know you're in here because I let you in. Franklin, what is A? 18z plus 14z. Franklin. Franklin, don't make me call home. Let's go, Franklin. Kill me, Franklin. Kill me, Smalls. Nikki.
32Z.
Perfect, 32z. Let's jump over to C because that one's easy. Let's pick on Isaac. Isaac, what'd you get for C? Did you get it, Isaac?
No.
No? Okay. So what if I said, what is negative 2 plus 4? You would say?
2.
2. So it's just 2x squared. And then because I want to give Chris Dolan a hard time, I'm going to make him do B. Chris, what'd you get for B?
Negative 2x to the 4th plus 5x minus 2.
All right, let's see. Yeah, Chris, there we go. All right, and I like the way Chris said it. And Chris, I don't know if you meant to say it or not, but you actually told me the answer in the form that I wanted, meaning I want you to start with the largest exponent and work your way down from there. So you started with x to the 4th, and you went to x, and then you went to no variable. So that's called standard form, and that's what we typically deal with in mathematics. Now let's keep going. All right. So on the next page, it says, simplify each expression by removing the grouping symbols using the distributive property. Jake, I picked on you last time. What does it mean to distribute? Jake, do you know? Oh, boy. All right, we're going to pick on Gabby. Gabby, do you know what it means to distribute? If I said, here's a bunch of books, distribute them, what would you do with those books?
I know, but I'm blanking.
Are you blanking?
Yeah, I know it. It's like,
if I handed you a bunch of books, they said, Gabby, can you distribute these? What would you do with those books?
like hand them out.
That's all you're going to do here. It's the same thing. We're going to hand that 3 out to everything in those parentheses there. All right, so we're just going to go like this, Gabby. Now, the back half's a little tricky because there's understood to be a 1 there. So we're actually going to distribute that negative throughout. So the first part becomes 3x minus 15. Do you see that, Gabby? That makes sense, right?
Yes.
All right. And then in the back half, this is tricky, okay? Kids often make a mistake here. They'll just write negative 2x, and then they'll write a minus 7. But what you have to do is you have to distribute that negative to that negative 7 to get a positive 7. All right? Julian, don't be that girl that forgets to do that. I know you won't, okay?
Okay.
Don't do
Yep.
it. Here we go.
Okay.
Now I have to combine my like terms. So I have 3x minus 15 minus 2x plus 7. So what I do is I'm going to do 3x minus 2x, that's x. Negative 15 plus 7 is negative 8. Done. Bada bing, bada boom. Coolest dude in the room. By the way, I'm the only dude in the room. All right. How do you guys feel with this stuff? Pretty easy? Do you guys feel
Yeah.
you guys feel you could do those problems? Why don't I let you do B, C, D, and E? I'm going to give you 5 minutes to do those 4 problems. All right? And then I'm going to walk through them. Sound good? You guys try it, and then I'll do it. You guys can do this. Cody Woolery, you hear me? Oh, boy.
Wait, what do brackets mean?
Same thing as parentheses. It's just you're going to start in E, you're going to start at the parentheses all the way on inside, and then you would move outwards towards the brackets. But you
Okay.
can treat them just like parentheses.
Thank you.
Sure. Is everybody done? Or do you guys need more time? Jake Stevens, do you need more time, buddy? Laura, do you need more time?
No, I'm okay.
All right, well then I'm gonna start. All right, I'm gonna try and do it like in my head. So if I make a mistake, forgive me. So when I did B, I got x cubed minus 16. Did we all get that?
Yeah.
Does anybody need me to do the whole problem out? All right, for C, Crystal, did you get that?
Yeah.
All right. For D, Ed, did you get that?
Yeah.
Nice. Noise.
17x over 5.
Yep. Ooh, this one.
Wait, with this one, do you have to like, do you flip the negatives, make the positive? Yeah, never mind.
Did I get it? 44a plus 8?
I got minus 22.
Yeah, I got minus 22.
It's definitely minus 22. I don't know what I was thinking. You gotta keep me honest. Any questions? Look at that.
I'm confused about C.
See? Gotcha.
Yeah.
Who said that? Hans?
Liam.
Liam. All right, Liam. So this negative 5x, we're just going to distribute that to each of the three things in the parentheses. So negative 5x times x squared. So x times x squared is x cubed. So it's just negative 5x cubed. Are you okay on that? Liam?
Yeah.
All right, so then we're going to do negative 5x times 4x. So negative 5 times 4 is negative 20. X times x is x squared.
Oh, okay. All right.
And then negative 5x times negative 1 is positive 5x. Are you guys good with that?
Yep.
All right. This is it. Last little bit. Now it says to evaluate. Evaluate means we are going to substitute a number for each variable. So in this case, we are going to substitute in negative 2 for each of the x's I saved. Okay, because it says it right there. So I'm going to say 5 plus negative 2 squared. So that gives me, let's see, negative 2 squared is 4, 5 plus 4 is 9. For this one, it would be 5 minus negative 2 squared. So 5 minus negative 2 squared would be 4, so I get 1. Are you guys following me on that? B would be 3 times negative 2. So that would be negative 6. And the last one would be 3 times negative 2 squared. Negative 2 squared is 4. So I just have 3 times 4, which is 12.